All right, so for our first example, we're going to keep it nice and simple. So we're given our function x, y, and z, and I'm just going to modify this so it's equal to 0. So this is 2x cubed y squared plus y z to the 4 minus xz. I'm going to move that 2 to the other side. Okay, and it wants us to find our derivative of x with respect to z. So we know that we just have to flip our values here. Right, so our x is at the bottom and our z is at the top, and these are going to be our partial fractions of our function. Okay, and when we do that, we are given, okay, so this is equal to, so negative, then we're going to use z first, so this is 4z cubed negative x. And then this is over with respect to x, this is 6x squared y squared minus z. Sorry, I forgot a y here. Right, and that's it for this question. You can put a restriction because we can't have anything divided by 0, so as long as 6x squared y squared minus z is not equal to 0. Okay, second question. This relation implicitly defines this function here as a differentiable function of x and z, and find dy dz at our x and z is equal to 1, 2. So let's find our missing variables first. So let's find our y. So we're going to plug in our values that we already know. So x is equal to 1 plus 2x, and then y cubed plus x. We don't know what y is. Z is 2 minus z, which is 2 to the power of 4 equals negative 15. So this is just 1 plus 16, and this is plus 2y plus, this is minus 16, I believe, right? Yes. So the 16 goes away, and we are left with 1 plus 2y equals negative 15. Let's move that 1 over. This is 2y equals negative 16, which means y is equal to negative 8. So this is the variable we're going to plug in. So when we write this term, dy over dz is equal to negative partial fraction of z, move that to the top, over partial fraction for y, and this is equal to negative, we're just going to start with z first, so this is xy minus 4z cubed, and this is over with respect to y, so this is 2x, actually I'm going to move that 3 down, so this is 6xy cubed plus xz, right, and that's it, and this is at point. So x equal to 1, y equals to negative 8, and z is equal to 2. So when we solve, this gives negative, so x times y is negative 8 minus 4, and our z is 2 cubed. And this is equal to 6 times 1, our y is negative 8 squared plus 1 times 2 is equal to, so we have negative 8, so this negative 8 minus 4 times 2 cubed. And so this is positive 40 on top. In the bottom we have, so that's 64 times 6 plus 2, 386 on the bottom. Sorry, I think I made a mistake when I calculated our y. Let's try again. Okay, that's what would be wrong. Okay, sorry. Okay, let's try this again. I will find y again, and I'll actually do it correctly this time. So this is 1, and this stays y cubed. Okay, so this gives 1 plus 2y cubed plus 2y. This is minus 16 equals negative 15. Let's move some of those numbers over. So we have 2y cubed plus 2y is equal to, we add that 16, so it's going to be 1. Then minus that 1, this is 0. So this is 2y, this y squared plus 1 equals 0. So then our y is equal to, hold on, 0 in this case. Y is equal to 0. Okay, so let me change that. Always be careful when you are doing these questions. Sometimes you may not have a second chance. Okay, so this is 4 times 8, so this is 32. And this is over, so this becomes 0. This is over 2. 32 over 2 is equal to 16. Okay, so that is our second question done. Okay, so we should move everything over for this one. And we're given the values of all 3 of our points, so we don't have to find for any unknowns. So let's just move everything over to equal 0. So this is going to be, I'm going to keep the left side the same. I'm actually going to change this and call this z to the power of 1 over 2. And this is minus 2 plus sine xz squared minus 4 over z. Okay, so same thing that we've been doing for our past couple questions is equal to negative partial derivative of f y, and this is over fx is equal to, so we're going to start with y first. This is going to be 2y plus z to the power of 1 over 2 minus 2, that's a constant, and we have x in here. Oh, sorry, there's no y in here, and there's no y in that one, so this is it for this one. So put negative in front of it. And then for x, with respect to x, we are doing, so it's constant, 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 and we can use this one. So this is going to be cos x z squared times the derivative of that x in there, which is just 1. So we're going to leave it there, and that's it. Okay, and we're going to plug in for our point, which is at x equals 0, y equals 1, and z equals 4. So that is going to give us a value of negative 2, then y is 1 minus square root of 4, and this is cos times x is 0, which is just going to make the rest of the term inside 0. Cos 0 is equal to 1, so this is just going to be our top term. So this is negative 2 minus square root 4, which is equal to negative 4. Sorry, I missed a step. Okay, sorry, this is like saying 2x, right? The derivative of 2x is equal to 2, right? So that's why we got to take this z squared and put it out in front. I apologize. Let me try again. So this is now equal to So we have negative 2 minus 2 over, and this is going to be 4 squared, so this is 16 times cos 0, which is just 1. Okay, and there we go. We have negative 4 over 16, which is equal to negative 1 over 4. Don't be foolish like me. Okay, so in each case, find the directional derivative of f at the point P indicated in each situation. Okay, so this brings us back to the first part of our notes section from the video. So this is going to be, so we're going to find our gradient first. It's equal to, okay, so we'll start with our x. This is 4xy minus 3y squared for our first one, and our second one is, so this is going to be 2x squared minus 6xy. And this is at the point x equals 3 and y equals 1. So when we plug that in, this becomes, so our 4 times x, so that's 12 times 1, it's 12 minus, and this is 3 times y squared, which is just 3. We have our 2x squared, so that is going to be 18 minus 6 times 1 times 3, so it's negative 18. It's going to be 12 minus 3 is equal to 9, and this is 0. And we're given our unit vector here, so if we want to find our directional derivative, this would be capital D. This is equal to, so we're going to have our gradient, the dot product of our given unit vector, which is 3 over 5 and 4 over 5. And this is equal to, so this is 9 times 3 is 27 over 5. And this would be minus 0 or plus 0. Doesn't matter in either case. And this is going to be 27 over 5. So that one is nice and simple. Okay, let's do a harder one. I want to do part D, and I'll leave you guys to do B and C on your own since they're relatively simple. Okay, so let's do D. So D is equal to, so this is like saying x minus y times x plus y to the negative 1. Okay, so we're going to start. So once we derive those, this is going to be 2y over x plus y squared. And this is going to be minus 2x over x plus y squared. Sorry, square should be on the outside. Okay, and this is going to be at point x equals 2, y equals negative 1. This equal to 2 times negative 1 for our y, and this is 2 minus 1, our denominator squared, and this is negative 2, x is equal to 2, and this is 2 minus 1 squared. This is equal to, so that's negative 2 over 1, it's negative 2, and this is negative 4. So now to find our directional derivative, we're given our unit vector. This is equal to negative 2, negative 4, with our dot product of 3 and 4. And this is equal to negative 6 minus 16, and this is equal to negative 22. All right, so moving on. Okay, so this is our last question here. So we're going to do part A and B. So given this function here, with respect to x, y, and z, find the directional derivative at this specific point in the direction from P to Q. So we're going to need a unit vector. So I'm going to find unit vector first. So we are directed from P to Q. That is equal to, so Q I'm going to do in green. This is 1, 9, 3. This is minus our point P in red. So this is negative 2, 3, 1. And this is going to be equal to, so this is 1 plus 2, this is 3, this is 9 minus 3, 6. And this is 3 minus 1, which is 2. And we want the unit vector. So this is our vector of P to Q over the magnitude of that. So that's going to be 9 plus 36 plus 4. And this is equal to, so 9 plus 36 plus 4, and their square root is equal to 7. So this is 3 over 7, 6 over 7, 2 over 7. Now I'm going to find the gradient at our point P. And this is equal to okay, so for x, that is going to be, and this is going to be x squared plus y squared minus 12z squared to negative 1 half. And this is times our derivative of x, which is 2x. Okay, so that is our first one. So our second one, same drill. I'm going to go through this one a little quicker. And that's times 2y. Second one, third one. Oh, this is going to be 6z. Negative 6z. What am I saying? Sorry, 24z. Okay, there we go. So I'm going to rewrite this. So these are going to cancel out, and this is just going to leave in our first term. It's going to give us x over the square root, x squared plus y squared minus 12z squared. For this term, this is going to be plus, so our 2's are going to cancel out once again, so this is y over square root of x squared plus y squared minus 12z squared. And finally, this is minus 12z over square root of x squared plus y squared minus 12z squared. Okay, and all of this is at point. So this x equals to negative 2, y equals 3, z equals 1. Okay, so when we plug that in, so let's just solve for our denominator first, so we can just kind of get it out of the way. So x squared, so this is negative 2 squared plus y squared minus 12. Okay, this is equal to 4 plus 9 minus 12. Okay, so this is 4 plus 9 minus 12. And this is just square root of 1, which is just equal to 1. So this means that we have, so this is negative, sorry, not negative, yeah, negative 2 over 1 plus 3 over 1 minus 12 over 1. Sorry, and these are still separate. Okay, so now when we do our directional derivative, this is negative 2, 3, negative 12 from our gradient, and this is with the dot product of our unit vector, which we found. Okay, and this is going to be, so when we take the dot product, this is negative 2 times 3 over 7, so this isn't equal to negative 6 over 7. This is 3 times 6 over 7, so this is plus 18 over 7, and this is minus 24 over 7. So that's negative 6 plus 18 minus 24 is equal to negative 12, so this gives us negative 12 over 7. Okay, so that's it for part A. And now for part B, let's do it in red. I'm going to find the unit vector in which the direction, which f increases most rapidly. So from our notes, we know that is represented by our gradient over the magnitude. So when we solved for our gradient, we got, so this is negative 2, 3, and negative 12. And we want to put this over the magnitude. It's equal to negative 2 over, sorry, let's find out what this denominator is. This is 4 plus 9 plus 144. Okay. I'm just going to keep that in its square root. So this is 4 plus 9 plus 144. This is equal to 157. So I'm just going to keep it that way. It's plus 3. And this is minus 12 over square root of 157. So this is our unit vector. And we want to find the rate and change of this direction. So we said our max rate is equal to our magnitude. So that's just our denominator that we found, which is equal to the square root of 157. Okay, so just like that, that's it for this question set. And that is it for this video. In our next video, we'll be starting section 3 of the notes, where we'll be talking about double and triple integrals. So this wraps up section 2 of the notes, where we are talking about functions of several variables. I hope you guys enjoyed. I hope you learned something, and I will see you in the next one.